Hello everyone. So we are discussing yesterday's paper, which was held in December 27, 2023. Here are the questions that we are going to discuss. The first question is: four distinguishable particles occupy 0 e 2 e energies. Okay, so number of microstat we need to find. Okay, and the one more information was given that such that total energy will be 4e. We need to distinguish these particles such that their total energy will be 4e. Now we know that for number of microstats corresponding macrostat, its formula is n factorial upon n1 factorial, n2 factorial and n3 factorial. By this we are going to distinguish this. First 0 energy E and 2E. So how they will become 4E energy. Okay. So let's say there is one particle, there are two particles. Okay. And there are one particle. So the energy will become 4E. So for them it will be 4 factorial upon 1 factorial, 2 factorial, 1 factorial, which will become 12. Same way here it is 0, here it is 0. There are 4 particles in energy E, so it will become 1. And here in 0 energy there are 2, in E there are none, and in 2E there are 2 particles. So by the expression we will get 6. So by adding all these things, okay, we will get 90 stats, macrostats. So that will be our answer. So this question is from quantum mechanics. Okay, psi is given like this, and we need to find out what will be the value of Lz if Lz operates on our psi wave function. Okay, so we know that it will give us mh cut psi. Okay, so we need to find this eigenvalue. So you may have learned this in spherical harmonics that for hydrogen atom, here psi is directly proportional to EIM phi. Okay, that is how wave function is related. So here in this expression, if we focus on this e raised to I phi, the value of m that comes out to be 1, because if we compare these two, okay, the value will be m is equal to 1. And also in spherical harmonics, if the wave function is of sin theta cos theta, sin square theta cos square theta, okay, you may have learned this that the the angular momentum will be if there are two functions sin theta and cos theta, and if their power is 1, that means the angular momentum will be 2. But for here in this case, we need this value m is equal to 1. So Lz is equal to mh cut. By putting this value in this, we will get h cut. That will be our angular value and our answer. Moving on to next question. The next question was from special theory of relativity. A rocket crosses origin at t1 is equal to 0 and x1 is equal to 0. These are the coordinates, space-time coordinates. Observer at origin sends light. Here it is sending the light, okay, signal towards the rocket. This is the rocket at t2 is equal to tau and x2 is equal to 0. Take speed of rocket as 0.5 c. Okay, rocket receives signal at t3. That means the time will be what and the position will be what. So there are three activities which are going on. Okay, rocket is going, observer is sending the signal, and rocket is receiving the signal. So first of all, when rocket is traveling with the speed 0.5 c. Now initially signal was not sent. Okay, when the signal when the observer is sending the signal, rocket must have covered this much of distance, okay, 0.5 ct, and their two relative velocity will be what, c minus 0.5 c. That means 0.5 c. Okay, distance covered is this, so that we can find out the time period. Okay, time period will be what, here the distance is 0.5 ct. Okay, so time period will be t. Okay, so time period is t. Now we need to find this t3. Okay, rocket receives light. When rocket receives the light, this is the third event. Okay, When rocket receives the light, it must have traveled some distance which is 0.5 ct again. So again it will take t time. So total time will be 2t and the position will be ct. So that will be the answer. Moving on to next question. This question was from EMT. There exists a magnetic field. This a bar magnet is kept in xy plane with its magnetic moment pointing in y direction. How will the magnet take this bar rotates and translate? So first of all, let's see in the figure that this is the bar magnet, okay, and its magnetic moment in y direction. Okay, and the magnetic field is in z direction, which is already given. So we know that when you put a bar magnet, if it is having a magnetic moment, okay, in here the magnetic field is in a upward direction, okay. So they are making an angle 90 degree or making some angle. So there will be some torque, okay, which is given by m cross p. Here m is in y direction and field is in k direction. So by the cross product we will get mb I cat. So that means it will rotate in yz plane, okay, not in this plane but in yz plane it will rotate. Now after some time it must have rotated like in this way, okay. Now it is, let's say, pointing in this direction, its magnetic moment. So its component must be there, one in y direction and one in z direction. We need to find its potential energy, so we can write it as m dot b. Now their component are my j cap, m and z k cap. So we can write it in this manner. Magnetic field is in still k cap direction. So by the dot product, this term will only this term will survive, okay, which is minus mz bx. Now we need to find the force. So fx is equal to minus del u by del x. We know that, okay. So by differentiating we get this expression which is not 0. That means our bar magnet will translate in x direction. So that will be the answer. Next question is that Lagrangian of a system is given, okay, and there were some options and we need to find out which one is correct for conserved linear momentum, okay. For that we can write the Lagrangian equation, okay. So for the x component, if we differentiate with x dot, we will get mx double dot plus 2 alpha is equal to 0, and from here we'll get x double dot. Similar operation we are going to do for y component and we will get z double dot is equal to minus 6 alpha upon m, and similar thing with, okay, for z component, and we will get y dot by 2 is equal to 5 alpha upon m. And by plugging these values in this option that was given, okay, we will get the answer 0. That means this is the linearly conserved equation. So thank you for watching and please subscribe and share this video, okay. It takes lot of time and effort to make these videos. Please share to your other friends. Thank you.